Okay, welcome again in the data structure and algorithms. So we already deal with the first section of the object-oriented programming, and we're going to continue with the next lesson of this chapter. So we already know about the basic concept of the um, object-oriented, and we already deal also some we already learned some examples on the object-oriented programming, and I hope that you can practice more about this object-oriented programming. And after we already learned most of the things, we are going to learn one more examples, and this example is from book. And I hope that the book, if you don't have the book, yeah, at least you can follow my lecture notes. And I guess there are also some resources in the internet about the books. So I'm using the book that I mentioned in the literatures before. It was the data structures and algorithms in Python. The authors are Goodrich, Tamasha, and Kurt Wurzer. It was published in 2013. So there's an example from the book about credit card class. So this class, the name is credit card, and there are 5 data members. So they already define the customer, bank, account, balance, and limit. And there are 7 methods: get customer, get bank, get account, make payment. Okay, you can see there's one argument, and get balance, get limit, charge, and we have one argument. Okay, so from this the class diagram, you can easily figure out the design. You can easily figure out the program that you want to make. Okay, and after you have this uh, design, the class diagram, then you can just put it into the code. Now you have the class credit card, and then you have the constructor. And yeah, this is the design that you can just figure out by yourself how many arguments that you want to use at the first time for the constructor. And in this case, there are there are 4. Okay? There are 4 data members that you want to use. In this are we have 5 data members, but the input or the when we want to create the object, there are 4 that we want to set for the first time. So the customer is the customer name, the bank will be the bank name, and the account ACND is the account number or the account identifier, and the limit is the information about the credit limit. And after we have those information, we put those information into the variable self dot underbar customer underbar bank underbar account underbar limit and underbar balance. So in Python, yeah, most of the programmers they know that the underbar means it is a public. Okay, but I guess I don't need to explain this more. Just you think that this is kind of the example to express the variable, so the other class can access this variable. Okay, because we are not discussing about the public, protected, and private, I will just keep this one as the public one. And after you have the first constructor, you need to define the other methods like guest customer, and then you will get the customer profile, customer name. If you call the get bank, you will get the bank name, and if you get account, you will get the account name. If you will call the get limit, you will get the limit. Get balance, you will get the balance. And the last one is the method charts. So whenever you do something, you will charts. Okay, so the charts, yeah, you can see there is a flow here. If the price plus the balance is greater than the limit, then it false. Okay, what does it mean? So the charts exceed the limit. Okay? So the price, something that you define here, is greater than the price plus balance is greater than the limit. Of course, you cannot use the credit card, right? Okay, then it will return false. If the balance so if this condition is false, then you will put the balance added with the price. So the balance will increase, and it will return true. Okay, so it means you can charge, you can just pay with your credit card, and you can do the make payment. How much that you want to pay is it depending on the amount that you put in the argument. So once you have the amount, then the balance it will be uh, decreased, or it will be subtracted with the amount that you have. So the balance will be reduced. Okay, you can check on the yeah, I already make this one in the Jupyter Notebook. Basically, this code is a Python file that is provided by the authors of the book, but I moved the content into this Jupyter Notebook. In the later chapter, I will give you the Python file, and you need to use this Jupyter Notebook, and those files will be in this folder. So whenever you want to use the Python file, then you can just use like what you already did for this auth event. So like you did this one, the import auth event 2, it means I'm using the auth event 2.py, and I want to access the method and so on. So you can do something like this one later. Now let's just use the file here. I have the credit card class, and I have the constructor with 4 arguments, and I have the get customer, get bank, and so on. So you already know this one. Now I have one main. Okay, what does it mean by main? Main is the command from Python in order to execute your class. Okay, so I want to create whenever I call the Python file, so the main method is there, and I want to call, yeah, I want to run this one. Okay, so what is this? We have wallet. Wallet is empty list, and I want to have wallet dot append. It means I want to have one more wallet. What is the first wallet? The first wallet is a it is an object. The object is a credit card, and there are 4 arguments: name, bank, identifier, account, and limit. The second wallet, we have the another object which is credit card with the name of John Bowman, the same, but different bank and different number credit card and different limit. And the third, we have also the same owner, which is John Bowman, but it is also in different bank, and it is different number and different limit. Okay, so you can see that there are 3 credit cards belong to one person. It's, yeah, I think it's common. Now you have, if you have the a good salary, of course you can get many credit cards. Okay, now you can check with the for loop. So I'm going to, yeah, this is just a random value from 1 until 17, and this random value will be the value for the charging. Okay, so the charging, you want to check if the charging can be applicable when the limit is already exceeded. So this wallet 0, it means the first credit card, and I want to charge. Okay, so I want to charge the according to the value. And the second is, yeah, the same. It is the second credit card and the third credit card, and I want to charge with the 2 multiplied by the value, and this is the 3 multiplied by value. So the value will be moved from 1 until 17, and then it will be updated, and so on. And after I do this loop, I want to check the credit card. So if the first credit card, then I will go to the first. So the C equals to the first credit card equals to 0, and then you will get the customer, get bank account, limit, get balance, and if the balance is greater than 100, then make payment. Yeah. If it is not greater than 100, then yeah, you don't need to do this loop. Now, let me run. Yes, there is nothing wrong. Hopefully, there's nothing wrong. Yeah. So the first wallet is from John Bowman. We have the California Savings. Yeah, the California Savings, and then this is the credit card number. The limit 2,500. Balance is 136, and the new balance is 36. Because it is greater than 100, you just pay 100 and then print the new balance. Okay. Now, what about the next credit card? Yeah, this is the next credit card. Is on the Bank California Federal. We have the account number. This one, the limit is higher than the previous one, which is 3,500, and the balance is 272, and the new balance is 172 because we just want to pay with 100. But you know that this is a loop. Okay, if the first balance is 200, then we pay with 100, and after that we pay another with another 100. So if it is already less than 100, then it stops. Okay. What about the last one? So the last one is also the same. We have the credit card from the California Finance. This is the account number. Then the limit is 5,000. But I want to check if it is greater than 100, because 408 is greater than 100, then we will do the looping. So we will make payment every 100, 100, 100, 100 until it is less than 100. So it becomes 8. Yeah, this is a good example, okay, to show you how we can use the class. So if you have the credit card object, or you have the class object, the class of credit card, then you can create the instances. Let's say you have 3 credit cards, then you have done with the first credit card, the second credit card, third credit card, and so on. We learn about the name main. It will execute all of the code found in the file, especially when you have the Python file. Okay, and it is a special variable when your module or code is imported by another, and when your module or code is the main program. Okay, so this is one example of the object oriented. Now I'm going to explain to you about the design principles. Yeah. What is the meaning by design principles in the object oriented? In object oriented design principles, there are 4. Yeah, there's some people mention there are 4 principles. Some people mention there are 7 principles, and yeah, basically there are 3. Okay, basically there are 3: modularity, abstraction, and encapsulation. And the polymorphism is a little bit complicated. I will just skip this one. Okay, so some people said they all because it will include the polymorphism, but in this chapter, let me just discuss about abstraction, inheritance, and encapsulation. The modularity is the process of decomposing a problem or program into a set of modules so as to reduce the overall complexity of the problem. It means when you have one big idea, you want to make it very small, 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 small. So the big picture will be based on the small picture, small picture, small picture, and you will combine all those things into a big one. So like this example, yeah, you have many functions and you will combine those into one, for example, application. Let's say if I want to calculate the median, do you know median? Okay, if you are calculating the mean, it is easy because you just sum all the numbers and then you will divide with the total numbers. But in the median, you need to have a very specific processes. For example, if you have this number 2.7, 3.5, 5.1, and 8.3, what is the median? Now the median is 3.5 plus 5.1. So we want to get the middle value, but it is an odd number, so you cannot get the middle number. Then we will check the number, the second and the third, and then we will add those numbers and divide by 2. Then we can get the result of median. If we have the odd number like this one, so 1, 2, 3, 4, 5, then we can easily select the median as the middle number. So first, what you can do to calculate the median is you need to sort the number. Okay, if the number is not sorted, then you need to sort the number, and then you need to check if the total number is in sequence is odd or even. And after you know that the number is an odd, then you will do with the mid value and divided by 2. But if the total number in sequence is even, then the median is the mean of the two middlemost numbers. Okay. If I can specify the process, then this one. The step to calculate median is first do sorting. So I can say that the sorting is the module 1, and then check odd or even. Then I can say this is the module 2. And then the last one is the calculation. So if odd number, then do this one. If even number, then do this one. So I can say this is the module 3. Okay. So if you separate into several modules, then it can be easier for you to develop the program. So you already know when we deal with the odd event. Okay. So odd event is only one function. It means if you want to combine with others, then you can try to make a new method or a new function with a sort. After you finish with the sort, and then you go to the odd event, and you can make another function which is median calculation. Yeah, for those things, yeah, you can make it as a module. The good things in the object oriented or the principle is how to make it as a module. And the other thing we need to understand is the abstraction. So abstraction means to focus on the essential features of an element or object in OOP, ignoring its extraneous or accidental properties. It means if you have known about vehicle, so I'll teach you about car, okay, before. So the car, actually, you have the all the properties, you have the blueprint, okay. What is the blueprint? Okay, cars have tires, car have steer, car have the machine, okay, car have seat, and car have mirror, car have window, okay, car have door. What else? Car have trunk, okay. So with those all features, yeah, so these essential features are relative to the context in which the object is being used. It means I can make a very big concept like vehicle, and the concept of vehicle, I can make it more detailed. Let's say I have a class of truck. Okay, okay, the truck is something that is very big. You can load a big goods, okay, a very heavy goods in the truck, and then the tires can be more than 4. Okay. But what about sedan? Sedan is also the same. They have tire, they have window, they have doors, they have a machine, they have mirror, they have window. Okay, but the size is smaller than truck. What about SUV? Okay, SUV is also a kind of vehicle, but it is bigger than sedan, but it is smaller than truck. Okay, so those are in the abstract class vehicle. So you can say that the vehicle is the abstraction of those classes. We can also have the abstract method, we can have the abstract class, we can have the interface as the abstraction. Okay. So method can be as abstracted, class can be abstracted. So this is the example of abstracted class, and also interface. But I will not discuss the interface here. So we will learn many things later in the examples of the data structure. We call it the abstract data types. The abstraction is to distill a system to its most fundamental parts, and applying the abstraction paradigm to the design of data structure gives rise to the abstract data type. So during the one semester, you will learn a lot about the ADD. You will hear a lot about this ADD. And an ADD is a model of data structure that specifies the type of the data stored and the operations supported on them, and the types of parameter of the operations. So you will learn later, if you will learn, for example, stack. Okay, this is one type, stack, and then you will know what kind of operation in stack. There will be push, there will be pop. Okay. So the ADD specifies what its operation does and not how it does it? You will learn that the process is here. You need to input, you need to output. You need to process like this, and you need to do that one. But when you want to do it in detail, you need to specify later for one particular application. For example, if you are doing with the stack for the mathematical operation, then the implementation will be different with using the stack for the checking the HTML files, okay, because they are both are different domain. So the collective set of behaviors supported by NAD is the public interface. I will skip the public interface. I will not discuss, but let's focus on the ADD, abstract data types. Encapsulation is also another properties for the object-oriented. So it is the process of binding both attributes and methods together within a class. So if we have the encapsulation, then it means I want to binding to those, and then we can just make it in another new class, okay, something like that one. So the internal details of a class can be hidden from the outside. If you have a class and then you have another class, we can say that it is encapsulated. The class has methods that provide user interface by which the service provided by the class may be used. And some concepts we will use that one for the encapsulation is the access modifier, like default, public, private, protected, class, or interface. But I will not discuss more about the encapsulation, even though you will deal with a very simple encapsulation with this, the inheritance, but I will not discuss in detail for the encapsulation. The next thing you need to know is about the iteration. Because the iteration is an important concept in the design of the data structures. Because iterators, it means you want to know if you have one list and then you have a lot of elements, then you need to go to the other element from one element. Then in iterator, there's a specific method or the special method, and the name is next. The next method is a method to return the next element of the collection, and it raises a stop iteration exception to indicate there are no further elements. So you already learned about the iterate, and then if you have the element, for example, you have 10 elements, then you will connect to the first element and the second element and third element and so on. So we want to iterate for all the elements. The iterators you have used in range, okay, you already know the class range. In Python they have one very specific range, so they start, stop, and step. It means whenever you use the range, you can specify what is the first number, what is the last number, and how many steps do you want. For example, if you put 2, then it will go every 2 numbers. So for example, 1, and then the step is 2, and then you want to set up to 7, then 1, 3, 5, 7. Okay. In Python, they have the length and get item. It means I want to know how many items in one range, and then you can get the item, or it means you want to get each of the number in the element. Okay. So you can check this one. This is the constructor. And then if the step is 0, then you cannot have the step 0. If stop is none, then it means the start is 0 and the stop is equal to start. And the length means this is the length, and then start equals to start, and the step is equals to step. And then if you want to do the length, then it shows the length, this one. Okay, so this is the basic method of range. And if you want to get the item, then you will check the k. What is k? So the k, if it is less than 0, then you need to include with the length. Okay, so the k will be added with the length, and you will check if it is in between, then you can try to do the what you want to do with the range. Okay, but if it is not in the range, then you will give the errors index out of range. Okay. So the examples of this range, I show you this. Oh, I guess I need to show this one first, but okay. Yeah, this is the range. Okay. Uh, yeah, I guess I need to put this one in the upper part because before this one. Okay. Yeah, range. So if you want to run this range, but I guess yeah, you need to specify with a very specific range. I guess if I R1 equals to range 1,9. Okay, so I can just say if R1 is yeah, so something that you cannot specify this one, but you can have the for I in R1, then you will print I, then you will see the numbers. Okay, so I want to see this R1, it is from the object. I'm making one object, and then this is the class range. I want to create the number from 1 until 9. So you know that the number is from 1 until 9. That 9 will not be included, so the result will be 1 until 8. Okay, so it's the same with what we already learned in Python before. The concept of inheritance is also one of the important issues um, in object oriented. Yeah. I'm going to discuss this one more detail because there are many examples later that you will use the inheritance. So inheritance means I have the hierarchical organization. So the below part will follow the upper part. This allows a new class to be defined based upon an existing class as the starting point. So if you have another class, then the other class will follow the upper class. The existing class is typically described as the base class or parent class or superclass. Okay? So there are some terms. And while the newly defined class is known as the subclass. So we will deal with this one later about the base class and the subclass. There are two ways in which a subclass can differentiate itself from its superclass. So the subclass may specialize an existing behavior by providing a new implementation that overrides an existing method, and a subclass may also extend. Okay, the keyword is this one. So you can extend or you can just specialize an existing behavior. What does it mean? Let's see. In the exception, actually, this is also a hierarchy. So the exception is there's a very general exception, but there will be a very detailed exception like value error, or there will be a very specific exception like zero division error. Okay. In other example, I want to show you the student object. Okay, you already learned about the student object. So we have the student name and we have the student city. Okay, we have the get student name, get student city, get student score, get set student score, and get student score. Now I'm making one new class. It's called class graduate student. So you know that the student, there is a bachelor student. What is bachelor? Aksa, yeah, and the graduate student, the Hakwan. Yeah. So when we are to, let's say I'm just making one new class, graduate student. So the graduate student will have very specific properties. If you are undergraduate student, you need to take 100 more credits. Okay, I forgot how many credits you need to take. Okay, so you need to take 100 credit, but for the graduate student, they only need to take like 30 credits. So the property is different. And for the graduate student, yeah, you will need to take some of the advanced courses, which is not available in the undergraduate course. So I just want to make very simple, like this one. So the graduate student actually, basically, they are also student. They have the student name, they have the student city, okay, and the score. Like the GPA, I think most of them are the same. Yeah, but there are some different. For example, now I'm making a constructor. Okay, the constructor consists of two. So it is student name and student city, and I call super. Okay, what is super? So super means when I created an object in graduate student, so I will follow the super, which is the student. So what is student? Here. So the property student name, student city will be in this graduate student. And I want to make the student name and student city, and this will be here. And the student city will be here. Okay. And I have self the max credit equals to 30. And this belong only to the graduate student, not belong to the student. If I want to access the graduate student, I can also access the method get max, which is the self max credit. So this is the class diagram. You have the class diagram of student. You know this one. And now I'm making a new class, which is graduate student. And this graduate student is a we have the inheritance to the student. Okay, so we have the student, this one. So if you want to access the student, you know that if we have the student object instantiation, you can specify the student and the name and the city. Student and the name and the city. So this is the result. Student 1, we have the Yahya Yongin and the score is 0. Student 2, Bernardo Sol and 0. Okay. Now, what about if you want to create an instance with the graduate student? You can have this one, the graduate student Yahya Yongin. Same. When you get the student name, you will have Yahya. When you get the student city, you will get Yogin. When you get the maximum credit, you will get 30. Why 30? Because the self-max credit equals to 30. But what about if I use the student? If I use the student, S1 is the student Yahya Yogin, I can get the student name, I can get the student city, but I cannot get the maximum credit because this student S1 belongs to student. Okay, it belongs to the student, but the G1 it belongs to the graduate student. So some properties are different, some methods are different. Because the get max credit is only available in the graduate student, then the student cannot access it. So if you want to check the example, yeah, I give you one example. This is the student. And you have the graduate student. I already explained the detail. So if you run this, I want to make one graduate student. And when you have the student name, yes, you get the Yahya. And then when you get the student city, okay, you can get Seyungin. And when you get the maximum credit, you can get it as 30. Okay. What about if I create the object from the class student? Okay, you can make the S1 get student name. Yes, Yahya. But can I get the maximum credit? No, because this is not the graduate student class. This is the student class. Okay. So that's the important part of the inheritance. Another example is from the book. Okay, the book provides you one example about the numerical. So it is numeric progression. It is a sequence number where each number depends on one or more of the previous number. Let's say if it is an arithmetic progression, it determines the next number by adding a fixed constant to the previous value. For example, if the constant value is 1, then just 1, 2, 3, and so on. Geometric progression is progression that determines the next number by multiplying the previous value by a fixed constant. If the fixed value is 2, so it means I want to multiply the number with 2. 1 multiplied by 2, 2. 2 multiplied by 2, 4. 4 multiplied by 2, 8. 8 multiplied by 2, 16. 16 multiplied by 2, 32, and so on. There's also another number which is Fibonacci. Yeah, if you already joined the computer programming, you will know the Fibonacci number. So the Fibonacci number is 1, 1, 2, 3, 5, 8. What does it mean? So 1, this is the first number, and 1 is the second number. And how can I get 2? 2 is the result of 1 plus 1. How can I get 3? It is the result of 1 plus 2. How can I get 5? It is the result of 2 plus 3, and so on. Okay. Now, I have the progression. So the progression, it means I know the starting number, I know the ending number, and I know there will be a step. Okay, so those first initial values can be defined in progression, but I can specify if it is arithmetic progression, then we will use addition. If we are using the geometric progression, then we are dealing with the multiplication. If the Fibonacci, then it has different formula. Okay, so this is the code. Okay, so in the progression, yeah, this is the initial value, the advance. Okay, you will add the current with one, and then you know the next, and then you will do the iteration, and then you will print the progression. Okay, if you are dealing with the arithmetic progression, then you will have a very specific this one. This is the constructor with the increment equals to 1, with the start equals to 0, and this is the super. Okay, what is super? Okay, I explained before, if the arithmetic progression, it is the inheritance, so it inherits from the progression, and we want to make a new we want to make a new object. If this is an object, then we will make the object according to the progression, and the start is the argument that you want to use from the constructor of progression. And yeah, you have also the same with the geometric progression like this one. So the current will be multiplied, okay, with the arithmetic. The current will be added, and the Fibonacci are, they are the same, but the Fibonacci will have different way to get the result. The previous, the current equals to the current plus comma plus the previous and the current. So if you run this example, okay, we have this. I already put this one, the progression and the arithmetic progression, the geometric progression, and the Fibonacci progression. Still the same with the previous example, we are using main. So once you execute the main, you will check this one. Okay, if you run, yeah, the default progression is a progression with the number 10. It means I want to get the sequence number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we have the arithmetic progression 5, it means I want to do with the increment 5. And the print progression 10, I want to print 10 times. So it means 0, 5, 10, 15, 20, 25, 30, 35, and so on. The same with the range. Okay, you have the 5, 2, and the print progression 10. Okay, so it means I would like to make the arithmetic progression with increment 5, and it start from 2. Okay, then 2 plus 5, 7, 7 plus 5, 12, and so on until 10 times. Okay. What about geometric progression? The geometric progression, yeah, we have the default, which is 10. If 10, then you want to make the 10 numbers with multiplication of 2. So 1, 2, 4, 8, 16, 32, 61, and so on. You can also make another type of geometric progression with 3. So 3 means the multiplier. Okay, you want to multiply with 3. Then 1, 3, 9, 27, and so on. What about the Fibonacci? So Fibonacci is also the same. If you're using the basic Fibonacci, then you will use the 0, 1, 1, 2, 3, and so on. But you can also deal with the different values. If I specify with 4 and 6, okay, then the two numbers will be the initial value, and 4, 6, and then we will check the next. If 4 plus 6 is 10, 6 plus 10 is 16, 10 plus 16 is 26, and so on. Okay, and we want to get 10 numbers. Yeah, I guess that's all for the object oriented. And yeah, next week we will learn about the algorithm analysis. That will be the chapter that you need to focus, because in this 3 weeks you will just learn about the Python and the object oriented, and from next week you will learn more about the algorithm analysis. So next week I think I will give you one quiz. Okay, so please check the announcement in the e-class about the possible quiz, and I will update the announcement according to my information. So thank you very much for listening. Hope you enjoy this course, and see you again.